so secret. It's so secret. It's an unfounded rumor.
That's right. Anyways, so last time we were talking about several different things, and a conversion tool idea came up that in terms of getting cryptocurrencies available for the masses, especially given its recent fluctuation, and I mean it's still, even over the weekend I would say it's become even more volatile. Bitcoin is still down. Gigahashes have actually gone down even more. They're like 0.0022 today.
Wow, yeah.
Yeah, I mean they've gone down even. I think it's right now it's like at 88 cents per gigahash.
80 cents per gigahash.
Yeah.
Oh
If you convert it to US dollars. I mean they're like almost free. Which is so I mean I don't really know what to think about that. Just kind of it's interesting. I bought more, but you know, am I just going to ride this thing down to zero? It's like, man, I bought 4 million gigahashes for free. And you're just mining these worthless coins. But in any case, something that came up was that it's inconvenient for people to really make purchases. And then we were also talking about, I think we were talking to a criminal, about what would you do about if you were to be given 5 Bitcoins, what would you do with them? Well, you basically said, I'm going to hold on to them till they're worth more than they're worth now and then sell them. At the end of the day, you wanted US dollars. Why?
So I could, or it's just more of an investment thing.
It lets you buy crap. If you want to buy crap in the United States, you need US dollars. You know, it'd be great if everybody just took Bitcoin, but let's assume everybody took Bitcoin today. Would you buy stuff with Bitcoin? It really does seem inconvenient, doesn't it? Because of how much it fluctuates. So even if you went into a place and they had real-time pricing, doesn't that still hurt your bottom line? If you have 30 Bitcoins in your account, let's say, and you're buying stuff with it, I mean, you might go, if you buy your milk on the wrong day of the week, you potentially could run into problems. Not even the wrong day of the week. What if you bought it in the wrong 5-minute period? Let's say Bitcoin's going all over the place and you happen to be in there and the price of milk was, you know, 0.0 whatever Bitcoins, you know, 0.0008 Bitcoins or whatever the conversion ends up being. And then 5 minutes later, Bitcoin drastically changes where you actually overpaid for milk. We wouldn't like that, would we? I mean, ultimately, what we want to do is we want a good deal. We don't care what we're trading. You know, human beings want good deals. And we were talking about one of the benefits of cryptocurrencies is that the transaction fees for buying stuff with cryptocurrencies are cheaper than credit cards. That's good. Why is it good? Because it makes it so that we might be able to get better deals. We compared it to the example, and I don't remember if I brought this up last time or not, and I don't know if they still do it. I don't think they do. But the Jimmy John's here in Mequon, in fact, I'm pretty sure they don't do this anymore, but they used to. The Jimmy John's here in Mequon when they were in their other location. So, and I remember this from like 4 years ago, maybe. If you paid by cash, it cost less money than if you paid by credit card. I think they charged you 25 or 50 cents premium if you wanted to swipe a credit card there to cover their fees they were paying to Visa or MasterCard or whatever, which, fair enough. Go ahead.
At all the grocery store, they don't do credit cards.
They don't take them at all.
They don't take them at all.
Yeah, and the idea is that because they don't take credit cards, they can make their food cheaper, less expensive, because you go to Sendix or Metromart, everybody's swiping a credit card. It's certainly, you're in the minority if you're paying by cash at a place like that. And they like it when you're paying by cash because you're a higher profit customer. They're having to pay less to Visa and MasterCard. Well, when you're dealing with Bitcoin transactions, since they are low cost to no cost, you don't have these processors, it's processed by the network in the middle, that seems to be a good thing if it was convenient for businesses to take them. And it was convenient for customers to spend it. So it was brought up that what if we can convert? We still bought things in US dollars. We still priced things in US dollars, which is stable. And then in real time, we converted US dollars into Bitcoin and paid in Bitcoin. But we didn't hold Bitcoin. So we weren't having to deal with the fluctuation of our bank account, our Bitcoin bank account, like that. We strictly used Bitcoin as a way to reduce the cost that the merchants are paying, which then gives us a better deal. Is that a model that's sustainable? Can we have a situation where Bitcoin exists specifically to be converted to make a transaction to be converted back, so that the actual transaction doesn't occur in US dollars, but it ultimately ends up in US dollars on both ends? Does that benefit us? If Walmart were to reduce their price by 2% on everything across the board, 2% across the board, because they no longer accepted credit card, instead they only accepted Bitcoin, and you had an app on your phone, if you will, so this is along the lines of the Apple Pay thing, except Apple Pay is based on credit cards. You had an app on your phone where you went up and you were buying your gallon of milk, which was, what's the gallon of milk, $2.68 or something like that, and instead of giving them $2.68 in cash swiping a credit card, you instead paid them this exact moment the equivalent in Bitcoin. And what you did is your bank account was connected to the app, which then immediately converted enough dollars into Bitcoin, $2.68 worth of Bitcoin. Then you paid for it via Bitcoin. And the processor on the other side then converted the Bitcoin back into US dollars. So you just use the Bitcoin as the processing mechanism, as an alternative to credit card. But ultimately, funds were always kept in US dollars. If that was convenient and it wasn't this, it sounds complex when we spell it out, right? But if it was convenient, is that a benefit? Could that be something that cryptocurrencies could be used for? To sidestep credit card fees? Possibly. As long as you don't run into conversion fees, right? So, those are things that we'll have to look at. But at the very least, that's a home for cryptocurrency that can exist. That's the idea of blockchain-based currencies where they're worth something without having to take over the US dollar. That kind of makes sense? In that case, if that were the case, does Bitcoin, if we assume it stays Bitcoin, does that need to fluctuate in value at all? If we just got into this situation where nobody ever held Bitcoin. We're all going to stick with US dollars. We're not going to hold any Bitcoin. Yet, we quickly convert to Bitcoin to make a transaction, which then gets converted right back to US dollars. Just taking the banks out of the situation, out of the middle in terms of their processing fee. Possibly. Okay, this is an interesting look. So, what I want to look at today is a website called Coinbase.com. This is one of the big Bitcoin exchanges. I'm going to go ahead and open it up. Open. All right, so here's Coinbase.com, and I guess it auto-logged into my account here. So you can see the different Bitcoin transactions that have occurred in here for buying and selling Bitcoins. So the way this works, if I want to go in here and I want to buy Bitcoin, so I click on buy and I can buy up to $1,000 worth of Bitcoin instantly if I really want to. The current price of Bitcoin is $402.02. This particular place happens to charge a 1% fee. So that would be something that there would have to be people that are willing to do these probably a bank that would be willing to do it for free and then make their money someplace else. But we're not going to worry too much about the 1%. We're going to worry more about the convenience of being able to do the conversion. Okay, as an interesting idea. So I can come in here and I can say I want to buy 1.0 Bitcoin, and current price is $402. I can go and buy my Bitcoin. It shows me here's the Coinbase fee, here's the bank fee. So I'm paying a total of $4.17 worth of fees for a $402 purchase. Okay, and then it would be in my account instantly because I can buy, I can do $50,000 worth of Bitcoins in a day on this account. but I only let me do 1,000 for instant. Otherwise, it takes about 4 days for the Bitcoins to arrive because it's connected to a bank account that is connected to one of my E-Trade accounts that can feed it, but it takes 4 days to do the transfer. So I can only buy up to $1,000 worth of Bitcoin in a day. But using Coinbase, would that typically be enough for most people to do normal daily transactions? Paying for a movie, buying a gallon of milk, lunch at Taco Bell, that kind of stuff. No big deal, right? You can work with $1,000. Okay? So anyways, this is what Coinbase is in general. Now they have an API that we're going to look at. Let me make this a little bit larger here. Okay, so they have an API that's the type of API is something called a Restful Api. And we'll talk a little bit more about that and what that means. But they have all sorts of different things that we can get at with our, let me look at what their documentation for this. I was just looking at this a little bit ago. Oh, API reference. So here's the stuff you can do. So we can get, after you've authenticated, we'll talk about how we can authenticate ourselves once you have an account with Coinbase. We can get our current balance. We can get our Bitcoin address. We can generate a receive address. That way, if we want to take a payment from somebody, we can have it go to a specific unique address just for that payment if we want to track it. We can do some account change stuff. We can get the user's accounts, the balance in Bitcoins. We can create a brand new account. We can add API keys to the account, get settings. We can delete an account. We can get some addresses. Here's how we authenticate. Here's another way to authenticate. We can do buy and sell buttons. This is how we can buy Bitcoin. So we're going to use that in our little application to say, I need to buy X amount of Bitcoins at the current price in order to pay for something. So when I go to buy the Bitcoin, and we'll see how this works here in a second. So if I need to buy enough Bitcoins to do $2.68 or whatever, and Bitcoin's currently at $400, $2.68 is 0.006 Bitcoins, right? 0.0067 Bitcoins. So I could say I want to buy 0.0067 Bitcoins and then immediately pay the address that for Walmart, grocery store, whoever you're paying. And then on the back end, it'll convert it back into US dollars for them, assuming there's no fees. So that's going to be the convenience that we're looking for to avoid the credit card fees for the merchant, so that hopefully they lower their prices so that we don't have to pay as much. So maybe it's $2.99 if we buy the gallon of milk with a Visa, or it's $2.68 if we buy it with Bitcoin. Something like that. So now, just to get started with this, we're going to look at a couple of these things. Quickly, we're going to talk about the difference between a get and a post. I'm going to kind of show that by example. So let's look at the exchange rates between Bitcoins and other currencies. So with their API, they have something, this is a get that does not require authentication. So we can kind of see how this thing works. So we're going to retrieve some information from Coinbase that's going to give us a document in a certain format called JSON that's going to tell us about all the different conversion rates between the US dollar and Bitcoin, the euro and Bitcoin, so on and so forth. Okay? And this is just a way that we can, with any application, we can just grab this information for free. We don't have to have an account at Coinbase or anything. So we're going to see this work. So I'm going to just grab this URL here, the /API/v1/currencies/exchange_rates. And I'm going to go to the Coinbase main site here and paste that in. I got an extra slash here. Okay. So this is a standard GET request. A GET request is the same type of thing that that a web browser does for us. Okay, and here it gives us this wall of information. That make sense? So we got this giant wall of information. If we look at it closely, we have a whole bunch of conversion rates. We have ARS to Bitcoin, 0.000295. MMK to Bitcoin, whatever that is. I don't even know what some of these are. It's actually giving stuff in all sorts of different, like the euro to Bitcoin. Here's 0.003191. Is what 1 euro buys in terms of a Bitcoin.
Bitcoin to US dollars is up.
Up.
Keep going up. Keep going up. Keep going up. And then over.
Yeah, right here. So 1 Bitcoin to US dollars is $402 and blah, blah cents. Okay, so this gives us a whole bunch of information. It gives us to it in a format that isn't really human friendly, but it is computer friendly. And we'll talk about JSON here in a few minutes. Go ahead.
So they set their own value to Bitcoin because it's a little higher than what the actual rate is.
Well, it depends. When you look at the rate, depends who you're looking at. If you look at the current value of Bitcoin, it depends how they're calculating that value. The value of Bitcoin right now is the price that you could buy it for if you wanted to buy a Bitcoin right now. And that's going to be generated by where you buy it from. If you went to Coinbase to buy a Bitcoin, it's going to cost you $402 right now.
Oh, so
If you go to another exchange and buy Bitcoin, maybe it's more, maybe it's less. So a lot of times when you look at these Bitcoin price trackers, what they do is they take the average of those three or something like that to give you a number that gives you a rough idea.
So there's really no universal value of Bitcoin then?
Well, there really isn't a universal value of anything. I mean, forget about cryptocurrencies.
I mean, stock exchange would give us the universal value.
No. It wouldn't. I mean, the price of Apple stock. I mean, you can buy stock in Apple on multiple different exchanges. You can buy it on the New York Stock Exchange. You can buy it on the NASDAQ. You can buy it on Great Britain Stock Exchange. I think you might be able to buy it in China. Same stock. Now, typically when you look at the current price of Apple, they're giving it to you on the NYSE, New York Stock Exchange. Well, even when you look at it, if you went to buy Apple stock 5 minutes later, are you going to get it for the price you just saw it? You're going to get it at the current ask price. So you have something with stocks, you have bids and asks. The ask is how much somebody who's willing to sell theirs is asking for it. The bid is how much somebody's willing to buy one is willing to pay for it. And usually those guys are a little bit off. And when does the sale happen? When you finally strike a deal. Somebody actually buys. Okay, so right now my guess is that Apple stock is in the $94 range or something like that. I know it was up over 100, then it dropped down to the low 90s, probably growing back up a little bit. But, that's good for this exact moment. At the time you actually execute a purchase is when you... so the price of anything is relative to what somebody's willing to sell it for and what somebody's willing to buy it for at the end of the day. McDonald's is always, if you go to McDonald's now and you go to McDonald's in 2 months, chances are the price of a Big Mac will be the same. Right? McDonald's is willing to sell you a Big Mac for $2.99 for the sandwich, whatever. I'm guessing that's about what it is. Because that doesn't fluctuate very much. But they could decide that the Big Mac has a greater value to the US dollar tomorrow and start charging you $4 for the $3.99 for that Big Mac instead of $2.99. Whatever. So in any case, this is giving us a whole wall of information in a format called JSON. And we're going to want to write a computer program that can kind of give us these pieces of information in a nicer to read format. Not just for us to read it, but for us to work with those numbers. And we're going to use this as our starting basis because when we ultimately start pulling information and start doing buys and sells with this, we're going to be working with authentication and working with real Bitcoin. But before we get to that, we need to know how to work with this data. So there's a couple different terms we need to understand. So let's go terms. We have something called a GET request. Okay? We also, and the counterpart is a POST request. And let me show this to you by example. Let's go into the desktop. So I'm going to create a little web page here to show us the difference between a get and a post. Okay? So we're going to create HTML. Don't judge me. We're going to create a little web form, and we're going to make this web form be based on a GET request. And we're going to put a couple of text boxes in here. So we're going to have input type is equal to text, name is equal to username, and we'll kick it down a line here. And we'll have another input type is equal to password, name. So name is the variable name, and we'll see this here in a second. Name is password. And we'll kick that down a line. No, we'll kick it down a line. And then we need a submit button. Input type is equal to submit. Instead of it just saying boring submit, we'll say do the request. All right, and we'll throw a couple of labels here before these. We'll say username, password. All right, so there's our simple little web page we wrote in HTML. How many of you have never seen or written HTML before? Yeah, have you actually seen this before? This kind of stuff? All right, so most people who work with web pages today use some sort of tool like Dreamweaver or something like that to do this crap for them. It's for wimps. You know, real computer scientists write their web pages by hand at the command line.
It's like people actually use real $100 bills.
Real people use real $100 bills. I just don't get it. When you can bleach once. It's just, all right, so we're going to go ahead and open up that page in my web browser. So I just created an HTML page. Web browsers know how to read HTML pages. So I'm going to go to File, Open File. I put it on the desktop. There's my blot.html. Oh, look how pretty that is. Just as I suggested it was going to look.
Your boxes are.
Are they?
Yeah.
Why is that? Oh, it's because passwords are shorter word than username. Should have put it inside of a table. All right, so anyways, now we're going to see what a GET request is like. Because if you remember, just going back here real quick, this web form, the guy that contains those two text boxes and the submit button, is going to try to call this program that I didn't write. So we're going to get a little stupid error. We don't care. We don't care about that page not found thing because we're going to look up at the URL. That's what we're interested in. Okay? But the method it's going to try to send this stuff is something called using the GET method. And what GET does is it sends all the information from our web form inside of the URL as public information. Okay? Now we would hate this because let's say we're logging into our account. So we're going to, here my username is going to be MUMBO1 and my password is my secret password. Oh, everything looks perfectly secure, blah, blah, blah. I'm going to go ahead and say do the request. It's going to say page not found. Can't find this file, but notice up here in the URL. Username equals MUMBL1 and password equals my secret password. Perfectly plain text. Replace that with your credit card information. How many of you would still order from Amazon if that's how it works? Probably not, right? All right, now let's go back. And let's go ahead and let's edit this code a little bit to do this as a post instead of a get. So get sends the form data through the URL. Now I'm about to trick you because I'm going to ask you in a second, why would anybody ever use a get? And you're going to originally say, well, you shouldn't because it doesn't seem secure. And then I'm going to say, well, when would you do it anyways? Because there are times. So we're going to make this guy a post now. So exact same page, nothing else changed. It's like now it's a post request. So we'll put in our username and our password again. I guarantee I typed the exact same password. I know it looked like I just banged on the keys. Totally didn't. We're going to say do the request. We get the same error down here, but notice we don't see anything up here. So a post actually packages up your form data and sends it as part of the post request, part of the request. Now that doesn't necessarily mean it's more secure. It's just less overtly insecure. Okay, it's packaged up in a nice little container that gets passed along with the request for our made-up page.php file that I didn't write. Make sense? If I want to write that page real quick. Oh, that's not going to work on here anyways. I don't have a PHP server, so don't worry about it. In any case, that's the difference between a post and a get. Okay? Get sends it through the URL. Post sends it behind the scenes. Why would you ever want to make a get? What's the advantage of a get over a post from a programmer's perspective? Or even from a normal person's perspective, but especially a programmer's perspective. Let me go back to the get here so we can see this. All right, so here's all the information right up here. What's the advantage of that? Go ahead.
Well, if you were just to use the get on the username part, then you'd be able to see that you're actually on your page that you're supposed to be on. Say on Facebook.
Okay.
If there was a special, if it showed your username in the URL, then you'd be able to see, okay, I'm on my Facebook page. But the password part, you would want to put in a post so that someone comes up behind you, they wouldn't see a password, just the username.
Okay, but from a programmer's perspective, what would we like about the get? I mean, you're telling me the difference between a post and get as to why, if we have a get from a user's perspective, it might be nice knowing that we're logged in as us, just to see our username up there, but we wouldn't want to see our password up there. Let's say from I'm an evildoer's perspective, so more along your lines. And I'm trying to hack somebody's Amazon account, because clearly this is how Amazon does their authentication, right? Okay, so what I'm going to do is I'm just going to keep building URLs. And we're going to say first password crack attempt. That one didn't work. Second password crack attempt. I don't have to manually go through a web form. I can just build that URL and just keep trying to hit this page, right? Over and over and over and over and over again. So that would be from more of an evildoer's perspective. What about the good side of that? What's nice about this is if I'm a programmer, this whole thing here is just a big string. I can build this URL. I can say, oh, username equals this, password equals this, replace username and password with something else. Replace it with, option equals 3, color equals blue. Something less secure. I can build that and everything else just updates. That makes sense? I don't have to go through the process of having to build a web form and submit the stuff by hand. I can just change it here. Seems to be convenient, right? Whereas a post, what if this made up page.php accepted a post. How could I build that manually? So we're going to change this back to a post. I don't think we went back that many times, so we're just going to... All right, so we're back to our post page, so we'll put in our MBL password. How can I spoof this? Can I write that by hand? A username and password was just sent, yet we don't see it up here. So if I want to manually change this, if I'm testing something as a programmer, I'm writing a website and I want to test to see how the colors change with those variables. I have to keep going back and going into the form and resubmitting it with a new color, where I could just change it up in the URL here and press enter if it was a get. Does that make sense? So post isn't necessarily better than get. We can say post might be more secure, but gets are often convenient. So when you're actually dealing with unsecure information, non-secure information, a get is usually better. In our example here, where we were looking at this get, we're not sending any information. We're just saying, give me the exchange rates. Let's click on this real quick and let's see if it gives us some more information. Does it allow us? Okay, good. So by default, we got this whole big wall of stuff because we didn't put anything up here, right? But when we look at the API documentation a little bit, it says we have keys for both BTC_2_x and x to BTC. So we have keys for doing some of those things. And we need to see how, give us an example how to do that, otherwise we just have to make a guess. So I'm going to make a guess on this. So we're going to say exchange rate. It's a GET request. So I'm going to put question mark key equals $_2_BTC. And let's see if we can get that conversion. I'm guessing that that's the name of the variable is key. No. Let's go back and look at it here. That's what I was kind of looking for. What's the name of the variable? Well, actually, hold on. We can tell what the name of the variable is. Well, you can tell what the name of the variable is. Maybe we can't. Let's go to the bottom here.
I think there's no variable, just a slash.
Yeah, you just have to slash it afterwards.
Yeah.
So it's
I thought I guessed it.
it's that. Yeah, no, it doesn't. No, that's it. Its success was false because we weren't authenticated. No, it has to be a variable. Wonder what they would call this. Just poor documentation. It has keys, so you can convert either way. The key always contains downward case representation.
Why did they say that, like with the responses in Bitcoin to whatever that is, and then they put a variable of the Bitcoin that they want to convert into the new? Like, are they putting information in?
Oh. That could be it. So maybe do US dollar. So this is actually the variable.
Yeah.
US dollar to Bitcoin, and we can say equals, let's do 200 US dollars. So that should give us roughly half a Bitcoin. Mm. Yeah, it's not documented very well.
Somebody asks in the comments to do what you're trying to do, and he says that that's not supported.
Oh, so they talk about it like it is supported, but it's not actually supported.
Are they trying to describe how it's formatted?
I think by keys,
They're
mean
talking about the contents
actual,
and
yeah.
the data that's in there.
Yeah, everything is BTC
Okay.
2 and then 3.
So this is a bad example for a get from the perspective of this gives us all the information we want, but this particular exchange rates file, whatever it is, doesn't take any inputs. So we can't actually go in here and say give us a certain something in here because it doesn't take any inputs. But we can write a program to fix that. All right, so in any case, get versus post has to do with how the stuff shows up in the URL here, but it also has to do if we're writing a piece of software to talk to something that's get or post, we have to send credentials differently. Either send the username and password differently or whatever. This particular API call that we're looking at here is a get that doesn't take any parameters. So we don't actually have any input. So this would be a very easy first one to try. Okay, so this will say shows in the URL. We're going to say does not show in the URL. A REST API. Well, here, let's just talk about API in general first. Abstract programming interface. A set of requests. Here, let's say a set of tools for communicating with a particular data source. So, for example, if you've ever used an app or something like that that says log in with Facebook or authenticate with Facebook, so rather than having to create an account with 40 different places, you can just always log in with your Facebook account as long as they support it. Facebook has an authentication API that allows different apps to utilize your Facebook account as authentication. So if they don't necessarily care about storing your a big old profile for you, they could still have a profile associated with your Facebook authentication. But if they don't necessarily care about actually storing your username and password and doing the validation themselves, they can ask Facebook, is this person the person they say they are? Then they can read in your name from Facebook, put it on your profile, and then they can ask for another 9 pieces of information if they want. So it's a convenient way for other applications to authenticate using Facebook. Facebook provides an API for this. Make sense? Now there's a couple of different APIs. Historically, well, in the early days, we would just have, proprietary APIs. So every single place that wrote an API would have their own little format for it, and there was no standard whatsoever. Then we had SOAP, which was our first standard for APIs. That was, so we'll call this first major standard. Then we have our modern ones. Not that SOAP doesn't exist anymore, but pretty much every new API that comes out is called a REST API. Now, REST is actually quite interesting. It leverages a very old technology, and that is, so it leverages the HTTP protocol in terms of its get, post, put, delete commands. So HTTP is the web protocol. Yeah, we looked at two of those today, gets and posts. So what was discovered is that pretty much anything we want to do in terms of an API could be accomplished in terms of these four different commands. We can get information, we can post information. So post is a way of getting information more securely. Putting is a way of putting information up there. Deleting is a way of getting rid of information that's up there. Make sense? So get and posts. Get would be like what we're looking at here. We just used the Restful API. We used a GET request, which is the default request in a web browser, to request some unsecure information. If we were to request some secured information, we would have to authenticate first. We'd probably use a post request. Okay, we'll look at that, but we're going to write this programmatically first. If we wanted to update something in the database, we would use a put. If we wanted to delete something from the API database, we would use a delete. Okay, and there's actually a couple of other commands that HTTP supports, but pretty much everything's defined in terms of these four. All right, so that's REST. All right, so we're going to be dealing with a REST API. Then we have data representation. So we have something called XML. That's extensible markup language. And we've seen an example of something that looks like XML today, and that is our web page. XML looks like this. It's a tag-based language where our data is actually stored inside of opening and closing tags. So here's the opening body tag, here's the closing body tag. Here's the opening form tag that has a couple of variables associated with it. Here's the closing form tag. Here's the open input tag that has a couple of variables supported within it, so on and so forth. That's XML. Okay? So XML is a data representation language. And then we have JSON. JSON stands for JavaScript Object Notation. JavaScript Object Notation. Let's just call it a more modern, more programming language looking data representation language. And what we see over here, I'll blow this up a little bit. This is JSON. Opening curly brace. Here's the variable name. Here's that variable's value. Here's the variable name. Here's that variable's value. So on and so forth. Okay? So this is pretty simple JSON. JSON also supports arrays, which XML does not. So kind of interesting stuff. All right, so that's some terms. Now, quickly, I just want to start a little Java program here. I know we only have a minute left, but let's just at least get the wheels turning on this. We are going to create a URL object. And we want this guy to be this URL. Okay? And it's going to want us to import java.net.url. So we highlight over that, import java.net. So now we're actually writing a Java program that's going to use the internet. We're going to talk over the internet. Okay? From our URL connection, our URL, we're going to create a URL connection. We'll call that con. And that's a new URL connection using the URL as a source. And it's going to want us to import java.net URL connection. Now this guy throws an exception, so I already got the throw exception in there. Oh, this isn't a new URL connection. It's the URL dot open connection. There we go. So we'll open that connection. Let me just write 2 more lines here, and then we'll pick up from here next time. So now I'm going to create a scanner, which we've seen before, is equal to a new scanner, and the input stream we're going to use is con.getInputStream. So the input stream associated with that connection, not our keyboard. So we didn't use system.in there, we used our input stream associated with the connection. Then I'm just going to do a system.out.println input. Next line. So create the URL, create the connection around that URL, actually create the way to read from that URL connection, read it in and print it out to the screen. We should get a nice wall of JSON as our output. Make sense? So we just created our own web browser in 4 lines of code. All right, so we'll pick up there next time because we need to start looking at how do we break that into variables that we can use. So we'll look at how do we parse JSON. I'll see everybody on Wednesday.